Hello everyone, my name is Thomas and today I'm going to present on vectors and embeddings. So have you ever wondered how Spotify knows what songs you like next or artists to recommend? The answer is simple and you probably guessed it, vectors and embeddings. You may have never heard of these or maybe you have. Regardless, our world practically runs on them now. In the next 5 minutes, I'll show you how machines turn words, images, and songs into numbers that preserve meaning and why that unlocks almost everything interesting in modern AI. So let's start with something familiar, a two-dimensional map. Every place on Earth can be located with just two numbers, latitude and longitude. Vectors work in a similar way. They have numbers that determine their location. Imagine this. Two cafes a block apart share almost the same coordinates. But when you compare coordinates of a cafe in Idaho to one in Japan, their numbers are very different. So coordinates give us a superpower. Closeness in numbers equals closeness in reality. If I want to know whether two places are near each other, I don't need to visit them. I can just look at their coordinates. Let me explain a few things. A vector is just a list of numbers. That's it. In trig, it's an arrow pointing to a spot in space. GPS uses two numbers, latitude and longitude, so it's flat, two-dimensional, easy to draw. Embeddings, which are vectors that hold some sort of meaning, do the exact same thing, except with hundreds or even thousands of numbers. You can't visualize a thousand-dimensional space, but the math works exactly the same way as it does on the map. An embedding is a vector that a model learns, with one goal. Similar things should land near each other in that space. So king and queen end up close together. King and banana are far apart. And here's what makes this remarkable. The numbers encode meaning, not spelling. So king and kind look almost identical as words, but they live in completely different neighborhoods of this space. Once everything has coordinates, comparing two things becomes very easy. Just measure how close their vectors sit. The most common way to measure vector distance is called cosine similarity, and the intuition is simple. Do these two arrows point the same way? If they're the same direction, the similarity is closer to 1. If they're different directions, the similarity is closer to 0. Using vectors and embeddings is really that simple. You just need to find out how far apart they are. So what kinds of things can we actually do with this? Here's the big one. Search by meaning instead of keywords. For example, if someone types, "How do I reset my password?" the best answer could be a document titled Credential Recovery Steps. Notice they have zero shared keywords. Old school keyword search would completely miss this. An embedding search nails it because the two land close together in meaning space. The recipe is 3 steps. 1, embed every document ahead of time. 2, embed the query when someone searches. 3, return the closest vectors. Done. And this is exactly how retrieval augmented generation works. It's how chatbots know your private data. You retrieve the closest chunks to the user's question, feed them to the language model as context, and it answers from material it was never trained on. Think of it as an AI tutor working from your exact course notes. And this is exactly what I'm doing for my senior project. An AI-powered learning management system where the AI chatbots are given context from notes and documents the user uploads. Once you see the trick, you see it everywhere. Recommendations. Netflix and Spotify put users and items in one shared space. So the "you might like this" section is just a nearest neighbor lookup. Clustering. Vectors that bunch together group themselves. Support tickets are all in one space. News articles will end up in one space. And spam and duplication detection, all of the like the spam mail will end up in one space. And cross-modal search. Put images and text in the same space, and you can search your photos by typing "a dog on a beach." That's exactly how modern image search works. So here's the whole idea in one sentence. Turn messy things into numbers that preserve meaning, then let the math do the work. Search, recommendations, RAG, clustering, they're all the same trick underneath. And when you need to do this at scale, using a vector database can store millions of embeddings and find neighbors in milliseconds. Next time an app seems to understand you, it's probably just measuring distance. Thank you for watching.